Now let's look inside one of these classes and see what's going on. Let's start with the shape class. A class can kind of be broken into pieces. First of all, we remember that the imports go at the top, and then we have the declaration of the class itself, which sets up its name. Then we see the body of the class between these curly braces. So these curly braces are always groups of statements. They delimit what we call a code block. So we saw a code block when we were looking at methods as well to collect all the statements that lived inside of a method. And control structures, which we'll see later, also contain code blocks. Inside the class's code block, we've basically got three groups of things: constants, fields, and methods. Not all of these things will be present in every single class, but usually there's a fair representation of each of them. So let's look deeper at each of these now. So let's start with the name of the class. Names of classes are chosen to summarize the contents of what's going into the class. So you would never have a class just called stuff. You always name the class after the grouping of behavior and data that are placed in there. So this class is called shape, and so we can predict that everything inside it has to do with being a shape. All the operations and behavior must be centered around that one concept. Interestingly, we can't really say the reverse, that every single thing to do with shapes lives inside of here. Like, we know that drawing at least knows about shapes and uses them for something. But we do know that if anything is centrally related to shapes, then it has to be in here in the shapes class. Right beneath the name, we see the class constants, bits of information about the class that don't change. These declarations need the keyword final, which means that they are immutable. They also usually have the keyword static, which just tells Java that they stay within the class rather than being instantiated with the object. They have a name, like shadow color, and they have a value that does not change. This is pretty much the same as what you've seen in previous courses, just with a slightly different syntax. And in this case, we can see that this shadow color must define some kind of color, and we can even have a little color picker here, so IntelliJ is very, very smart. So we can change this to a lovely blue, and then if we reran our drawing editor, we would see that something's changed. So how about you do this? You can open up your code for drawing editor, change this color, and rerun it. And you'll see that the shapes are blue, or whichever color you've chosen. And again, all these names are chosen incredibly carefully to make it explicit to the reader what they're used for. So if we didn't like a word like shadow color, if we didn't think that was a meaningful name, we could instead call it something like playing color after we discovered exactly what it does. But don't just change it in place yourself. You have to do it officially. So you would select it and click Refactor Rename, and then that changes it absolutely everywhere that it's used or defined. So next we have fields, and they are variable declarations. And we've looked at variables already, so you know what those look like. And every one of the fields has this additional piece of information, this public and private keyword, which we're mostly going to ignore for now, but we get into pretty deeply in a later video. Fields are basically the information that is stored about a class, the data. So here we can see that there are lots of fields. So we have X and Y, and those are probably coordinates of the shape, and width and height, they are probably the width and height of the shape. And then we have selected, which is a Boolean that must be whether the shape is selected or not. And then we have the instrument, and that's probably what plays, and then the line coordinate, which is also pretty simple. And then we have one field that doesn't use one of the Java types to declare itself. Instead, it's using one of the types within our project, specifically the MIDI synth. So we can see that class over here if we look inside the sound package. This is why the drawing had to import the sound package so that it could get at this code inside of the MIDI synth. So sometimes classes have fields that are types defined within the project itself. And then the bulk of the class is usually the whole collection of methods or operations that the class provides. And there are lots and lots of methods in this class. That's completely typical. So if we look at the structure panel, we can see all the methods and browse around them using that. So at the top of the methods is where the constructors live. Now these are the methods that are called when you call new and then the name of the class. So like before we said new dog, and that call would then call the dog's constructor. So as I said, these always live right at the top of the class, and they're always named exactly the same thing as the class itself. So here we can look and see that there are actually two constructors. Later in this course, we'll see how it's completely fine to have methods of the same name as long as they have different parameter lists. And you can see here that these comply with that rule. They have different parameter lists. So we'll get more into the implementation of the constructors and how they run really, really soon. But basically, what you need to know right now is that these set up all the necessary state for the object.